Hi, my name is Agis Economou. I'm the principal data scientist of the AI department in Kaizen Gaming. And I'll be speaking to you today a bit more technical than the rest of the presentations here about the Casino Copilot, a product that we launched in August. And with that, I'll dive a bit deeper about how technically you develop such a service. So first, I'll quickly speak a bit about our company, what the Casino Copilot is, and then what's the anatomy of a GenAI-based Copilot service. Then I'll pick a few topics which I think are interesting on how you develop such a system, and finally wrap it up with what are some design choices people need to consider when developing such a system, and what's the future. So who is Kaizen Gaming? We are a game tech company. We are focused on delivering excellent entertainment experiences, and our products are casino and sportsbook, mainly. And Casino Copilot, essentially, it's an assistant for the casino version. We don't have any physical presence. We're completely digital, and that's why we invest a lot in technology and AI specifically. So normally here there'd be a video about the Casino Copilot, but I'm not sure it's going to play, so I'll speak about it. So the Copilot is a personal assistant AI for the casino. In this case, it has multiple personas that you can speak to and ask questions about casino games, get recommendations, ask about instructions on how to play, and generally how the site works. And typically, going behind the scenes of such a system, the expectation is that you've got something like this. You've got your user question that the customer is going to ask. You use some information retrieval to get the relevant information. Then you use the LLM to generate a reply. And finally, you send that reply back through the Copilot to the customer. The reality, though, is a bit more complicated. As you can see, this is far closer to what's a production system like. You've got the user question, and you've got to handle the session, because you might have like a longer conversation, you might have like multiple conversations with the same customer, and you need to take that into account. You've got to guardrail and control what the customer is saying, because it might be completely irrelevant. You need to refine the question in order to make the information retrieval work. Then finally gather that information, move to personalization before you go to the actual LLM that generates a reply, and answer the customer. And besides that, you also need to manage the sessions, have an evaluation system, manage errors, have the UI, integrate with every other backend service of your system. Maybe you have pre-prompts to guide the customer with specific questions, because most people are uneducated on how to use such a system, and different LLMs have different expectations in your app, so it's good to show the customer how they can use it, how you manage information, caching, which is a very underrated topic in LLM generation, guardrails, as I said, and issues like anonymization and how to avoid personal information, and finally tracing and monitoring of your system. As you can see, it's much more complicated, and I don't have the time here to go through everything, so I'll focus on personalization, evaluation, information management, and guardrails, which I think are important. So we'll start with information management. What we are interested here is how we can get accurate and relevant replies to our customers. And the best way to do that is to get the most relevant data. But how do we get it? Most people will say use semantic search, but is that really enough? And what happens if the question is ambiguous? Like for our use case, if someone asks, I want a beginner-friendly game, what does beginner-friendly mean? And also, what's the lifetime of your data? How often do you need to update it? When it dies, do you need to recreate all the embeddings and everything? So some solutions here is first use hybrid search, which essentially is a combination of semantic search which is what everyone is using right now, plus traditional keyword search, and you can leverage the strengths of both approaches. Secondly, you can restructure and change the customer query, either by changing it in a format that makes it easier to get the relevant information, or by even creating a new database query based on that you use to get the data. Finally, besides changing the question of the customer, you can also change how you store that information in your database. So instead of just taking the text and embedding it, you can generate questions, for example, where that text answers the questions, and then do semantic similarity of the customer question to the question you generated, which obviously works better as you are comparing pairs with pairs and pairs with apples. And the last thing you can use here is use a reranking algorithm like cross-encoder models, which are much stronger and better at retrieving the correct information. And the idea here is that you use the first part to go from the millions of documents you might have down to the thousands, and then go down from the thousands to the few that you're actually going to use in your reply. The next topic here is guardrails. And guardrails are important both in a sense of protect yourself from what the customer is going to say and from what you will generate. Because customers might ask irrelevant questions, so they might ask questions which are relevant, but you don't want or can't answer, because maybe it's private information, or they might even be just trying to break the system completely. And also you've got the other side of the coin, where your answer might be generated and be broken, or hallucinate and say something that doesn't exist. And there are a number of solutions you can try here. The first is most cloud providers use and provide some type of content filter service, which is going to immediately filter out explicit content, sexual content, stuff that you don't want to generate. But you should be careful here for false positives. Then you can also use like a specific model to classify the input and decide how you're going to handle it, either by traditional LLMs or even with a specific ML model. You can also, for the hallucination issues, give the LLM the option to not answer, which is always important, because otherwise it's always going to try to provide something that looks lifelike and correct, and it's not. So, for example, in a classifier, you tell it if you can't classify this or are not sure, say I don't know or unknown. And another technique that helps is chain of thought, where you ask the LLM first to go through the thinking process of how it reaches its conclusion and then generate whatever it's going to generate. And this tends to both reduce hallucinations and improve your results. And finally, you can use external models, like factual inconsistency models, that check the generated output with the context that you gave it, like the information that you retrieved, and see if it matches or not. And there's a ton of models like that from traditional LNP that can do that, like classic NLI models, and can help you avoid issues and inconsistencies. Now, the next topic is personalization, and here I mean how do you make the assistant unique and different from just another assistant that speaks in the same way, and how you can add a bit of a wow factor as well. And the answer here is both on the prompting side, where you can add role-based prompting and give it like a persona with examples and a backstory, and that's going to help it give you a much more unique and personalized reply. And obviously, you can iterate with self-prompt tuning to improve the result. But also here, you need to go beyond the LLM solution and actually have an avatar, create a unique UI, and if you're using voice, even have like a different voice synthesis. All this adds flavor and character and a unique personality. Finally, how you evaluate the system. And here it's a very open, broad subject, like how do you test chatbot conversations in the first place? And how do you even define what is a good reply or not? And if you have a system and you change something, how will you measure that you've improved it and you didn't break stuff? And this is still a very open topic, but here are a few things that you can try. The first is separate the information retrieval evaluation from the LLM evaluation. Information retrieval is a known quantity. There's standard metrics to use, and you can be fairly certain that if you retrieve the correct information, the answer is probably going to be quite good as well. So instead of trying to give everything to the LLM and hope for the best, it's better to pinpoint the best information you can, which is measurable, and then focus on the generation of the LLM having that information. From there on, you can definitely create unit tests, and especially for edge cases. For example, like if the question is out of topic, then you kind of know what the LLM has to reply. And beyond that, there are specific things that you can check, like the accuracy of the reply, the coherence of the reply, if the persona is matching what you want it to. And you can do like human evaluation or use LLM as a judge. In that case, use pairwise comparisons and never ask for absolute scores because they don't work that well. And even in the pairwise comparisons, be careful for positioning bias and make sure that the answers correlate with human evaluations. Otherwise, you need tuning. Remember to always test for long history sessions, because in typical testing, you might only ask a question reply, which is not reality if you can have a multi-step conversation. And this can completely break your system. And finally, invest some time to have your own manual evaluation tool. Because going through an Excel spreadsheet hundreds and hundreds of times to check answers can be quite painful. And a few hours of Python can really make your life easier. If you can afford it, do a UAT and have specialized QA people to go through the system as well. So if we put this all together, we get a system like this. I didn't go for a live demo, because notoriously these break, but feel free to log into our site and play with it. This is live and working. So we've got 3 different characters here, Rookie Rick, Expert Emma, and El Profesor. They all speak in different styles, have a different backstory. Rookie Rick is a newcomer, Expert Emma is there for fun, and El Profesor knows all the details behind. So you'll see different replies, different strategies that they can give you. For example, El Profesor on how to play and how to win. Going back to the system, here are some questions that you should consider when designing it. There's a lot of discussion right now about retrieval augmented generative systems, if they are obsolete, and since LLMs can fit a lot of information, maybe we don't need that information retrieval. But the reality is that the more information you give it, the more easy it is for it to make a mistake or go completely in the wrong direction. So it's better to have specific information that you know is correct, and that will guide your LLM to the correct answer. And then, is semantic search enough? You'll hear a lot about vector databases and how they are the future, but semantic search has a limit, and the more documents you have and the more similar the documents are, it doesn't work that well. In reality, hybrid approaches, having filters, anything that you can reduce the space is going to make your system work instead of going pure semantic. In some cases, especially if the documents are not a lot and they are diverse enough, semantic search works great. And in the hundreds and thousands of rates, you probably don't need anything else. Now, another thing, which is often neglected, is how do new models affect our system? We get new models every few months. We've got companies competing for the best model out there. We've got closed source, open source models. they change all the time. And even the models as a service, they will probably be deprecated in a year. So you need to design a system which is flexible, and you need to consider that you will be changing the models relatively often, and don't put all your hands in the same basket. Another thing you hear a lot is, should we use an AI agent? And the idea here is that the AI agent can speak to itself and ask more questions to get to the right answer. Depends on the use case. Maybe it makes sense, maybe not. But don't forget that every time the AI agent calls the LLM or a tool, you're paying money, you're adding lag to your system, and this can very easily go out of hand. So you always need to consider the cost and latency that gets added here. Then what about automated prompt engineering? And that's also an active research topic, something to look on. In my experience, if you know how to do prompting and follow the main guidelines, you can get a much better result faster than relying on automated prompt engineering. But maybe in the future, we won't need prompt engineering at all, and the models will be strong enough to handle it by themselves. As I said before, you need to consider the scalability and time constraints. Having a lot of LLM calls can be expensive and time-consuming, and it might be better to have LLMs do very specific tasks, but this gets very slow very quickly. So compromising and having one call do multiple things maybe is a better approach depending on what you're trying to do. And always remember, how do you scale, what kind of services will you use, and because especially with LLMs as a service, it's extremely easy to run into throughput constraints and token constraints as you are scaling. Finally, considering the future a bit and where this type of technologies can get us, the first is how far we can go with personalization. Can we do customer-specific personas, where every customer has their own personal assistant which has a completely unique role and way of speaking for them? And secondly, can we go in the other direction and have the Copilot replace search completely? And maybe you've heard of Perplexity AI, which does exactly that. And essentially, it gets information, gives you the answers, but that has very good results if you're looking for something but you don't know what it is. But if you know exactly what you want, then you have to wait for the reply. So it's still an open-ended thing on how to get there. And finally, for us as Kaizen as well, obviously the next step is how do we go to more to the other side of the market, like sportsbook, real-time dynamic information on everything. And that's still an open topic on how you can manage that information quickly so you can have real-time generated replies. So thank you so much. I think I have time for one question. Otherwise, feel free to come to our booth, where me and my team will be happy to take questions from you and even dive deeper in these technical points.